Okay, this is Factoring Polynomials Part 2. I'm going to work a problem or two from last night's homework, and then I'll work a couple problems from tonight's homework so that you can get a little head start. This first problem is from last night's homework, and this is in the section that specifies that you should use the pattern for sum or difference of cubes to factor this problem. This particular problem is difference of cubes because there is subtraction, and because the first term is a perfect cube, and the second term is a perfect cube. So the very first thing I'm going to do is write down my pattern so that I remember it. So if I have the problem a cubed minus b cubed, I know that when I factor, I'm going to get a squared, ab, and b squared. And then I'm going to use my little acronym SDP to figure out that because it's subtraction, I need the same sign, then a different sign, then a plus. So this is eventually what I'm going to fill in the blanks for. And for my original problem, I'm going to identify the a cubed. The first term is x cubed. I'm going to identify the b cubed, which is 216y to the 6th. Notice I'm not paying any attention to the sign of 216. That's going to be taken care of in our pattern when we have the sign in there. And then from here, I'm going to identify what my a and b are. So if a cubed is x cubed, then a has to be x. If b cubed is 216y to the 6th, the cube root of 216 is 6, and the cube root of y to the 6th is y squared. Okay, and if you need a little refresher on that, if I multiply 6y squared times itself 3 times, 6 times 6 is 36, times 6 is 216, and if I have 2y's times another 2y's times another 2y's, so that's y to the 6th. Remember, you add the exponents, or you can think about expanding them. Okay, from here, I'm going to use my a and my b to fill into the pattern. So I have x minus 6y squared, that's a minus b, times x squared. My b squared is going to be 36y to the 4th, and again I'm just taking the b value here and squaring it. And in the middle I'm going to have 6xy squared, and I'm going to make sure that I put my signs so I have the same sign as the original, different sign, and a plus sign always at the end. This problem comes from the guided practice on the back of tonight's homework, and I just wanted to go over this one to make sure that those of you who are struggling to factor completely have another example to look at. So when I look at this one, first thing I notice is that there are two terms, there's subtraction, and I see that both of the terms are perfect squares, so I know I'm going to start by factoring this using difference of squares. Difference of squares, remember, is going to have two factors, and to find what goes inside, I'm going to take the square root of the first term. So the square root of x to the 6th is x cubed, and the square root of 64 is 8. And then for difference of squares, one is a plus and one's a minus. From here, I need to check to make sure I can't go any further. And it turns out, if I look at these two sets of parentheses, both of these can be factored further. So in the first one, I'm looking at a sum of cubes problem because x cubed is a perfect cube and 8 is a perfect cube. And when I look at the second one, it's a difference of cubes problem because it has subtraction. In order to factor this further, I'm going to figure out what a cubed is and what b cubed is. And then I ultimately want to know what a and b are. And because the terms are the same, one's a plus and one's a minus, this initial step is going to apply to factoring both sets of parentheses. So a cubed is x cubed, b cubed is 8, which is going to make our a plain x to the first power, and b is going to be the cube root of 8, which is 2. So I'm going to use these two pieces of information to factor using the sum of cubes and the difference of cubes. And remember, if you don't have these memorized, you need to have access to these patterns at all times. So x cubed plus 8 is the sum of cubes pattern. I'm going to start with a small set of parentheses, and a and b go in the parentheses, and I'm going to use my acronym SDP to help me out. Same, so it's going to have the same sign. Next, I'm going to take and I'm going to square a and b, so I have x squared, and I have 4. And in the middle is a times b, so I have 2x. So we've got the same sign, then I need a different sign, so it's going to be negative, and then the last one is always plus. So this particular set of factors is equivalent to this factor up here. They're the same thing. I also have to finish factoring x cubed minus 8, and it's going to look very similar. I'm going to take a and b and put them in the first set of parentheses. I'm going to take a squared and b squared and ab and put them in the second set of parentheses. And I'm still doing same different plus for the signs. So the first sign has got to be the same sign as my original, so it's going to be minus. The next one has to be different. The third one has to be plus. So my final answer for this initial factoring problem would be what I have boxed here. This problem is problem 20A on the homework, and it says to factor the following using quadratic patterns. And all you need to know about what quadratic patterns are is that it's the same as factoring using the X box that we've already practiced quite a bit. So if I look at this problem, first I'm going to check for a GCF. When I look at my three terms here, the GCF is 1, so I know I don't have to factor anything out before I begin with the X box. In the X, in the top, we do A times C. A is 1 and C is negative 6, so we're going to get negative 6. The B value is negative 1. And so I'm thinking of two numbers that multiply together to give me negative 6 and add up to negative 1. And I believe that negative 3 and 2 should work. When I come over here to fill in my box, the first term always goes in the top left. The last term always goes in the bottom right. And then what I'm doing is I'm literally taking this term here, and I'm going to split it up using these magic numbers here. So when I add these two together, I need to be able to get negative x squared. So I'm going to put negative 3, positive 2, and then we're used to putting an x next to them when we did regular quadratics, factoring quadratics. When I take a look at this, my middle term is an x squared term, and so the diagonal is going to take on an x squared as well. This way, when I combine like terms, if I add negative 3x squared plus 2x squared, I'm going to get negative x squared. So these three right here, this has to equal these two put together. So when I factor, if I look at the top row, they have an x squared in common, so I'm going to factor out an x squared. When I look at the bottom, they have a 2 in common. And that's going to make the top x squared and minus 3. So my final answer should be x squared minus 3 times x squared plus 2. And remember to always go back and double check to see if you can go any further. So if I look at this factor, I have a perfect square and I have subtraction, but my my second term here is not a perfect square, so there's nothing I can factor here. If I come look here, again I have a perfect square, 2 is not a perfect square, and it doesn't have subtraction, so I know that I'm also finished there. So that completes this one. The instructions for this homework problem say find the zeros of the function by factoring and using the zero product property. The way that I have it written here is the same instructions. It's already set equal to 0, so I'm going to be finding the zeros regardless. Before we begin, just remember that a polynomial has the number of zeros of a polynomial is the same as the degree of the polynomial. So the biggest exponent, or the degree of this polynomial, is 3, so I should be expecting to have 3 zeros at the end of this problem. Very first thing I'm going to do is take a look and see if I need to factor out a GCF. So if I look at the three terms, I notice that they are all divisible by 3. And I also notice that each one of them has at least an x to the first power in it. So I'm going to factor out a 3x to begin with. And when I do, I'm going to see what I have left over. So 3x cubed divided by 3x is x squared. 3x times negative 2x is negative 6x squared. And 3x times negative 15 is negative 45x. Okay, so step 1 is factoring out the GCF. If I wanted to check this, I would need to take 3x and distribute it to each of my terms to make sure that I got what I started with. I'm not going to do that because I'd be working backwards, but that's how you check to see if you have factored out the GCF correctly. The next thing that I'm going to do is take and I'm going to do X box factoring with what's inside here. So first, in my X, I need to do A times C, which in this case is 1 times negative 15, and they need to add up to negative 2. So I'm thinking of 5 and 3, and the 5 has got to be negative if they're going to add up to negative 2. Moving into my box, I'm going to have x squared minus 5x plus 3x minus 15. And when I factor that, we should get x minus 5 and x plus 3. So I'm going to write my factors, what I have now. I have 3x, okay, that comes from the GCF, 3x times x plus 3 times x minus 5, and the whole thing still equals 0. Just accidentally erased part of the problem, so hopefully you can still understand what we're doing here. So next I'm going to take and I'm going to set each of the 3 factors equal to 0 separately. And I'm going to solve these little baby equations. And my final answer, the 3 zeros that I'm looking for, are right here.